Hey class, welcome to the last week of the school year here. I just want to say, thank you for all of you that have participated these last 7 weeks. You guys really did a nice job, and hopefully you guys learned a thing or two through this process. So this last week is going to be just like a normal week here. We're going to finish up the school year learning to solve quadratic equations by inverse operations. So we'll have a couple of days of notes here with a couple of homework assignments. And then on Friday, there'll be one final quizzes. And that's how we're going to kind of wrap up this school year. All right, so today is going to be day one of solving quadratic equations by inverse operations. All right, and so to begin today's lesson, I actually want you guys to do a little warm-up problems. All right, see what you do with numbers 1 and 2 here. All right, and this is about, just a review. All right, so number 1 is you're just solving that equation, right? This is a two-step equation for number 1. And then on number 2, right, it's just simplifying that radical, right? The square root of 24. All right, and I want to see you break it down and see what you get for your simplified final answer. All right, so just try your best for number 1 and 2. So go ahead and pause the video and then see what you get. All right, so let's see how we did here. All right, again, both of these are kind of a review of what we've done this year, right? With number 1 being something we did a while ago, right? But that's just your basic solving two-step equation, right? So first we want to subtract 7 from both sides. And then we get 2x is equal to 19 minus 7 gives us 12. And then we divide by 2, we divide by 2, and we get x is equal to 6. All right, so that's my solution for number 1. All right, number 2, it's what we learned last week, all right, simplifying this radical, right, the square root of 24, right, this is where we want to break up this rad 24 into two radicals. All right, so some perfect squared number times another factor. All right, so we take that 24, right, and we find the largest perfect square of 24, which is going to be 4, right? And then another factor to get back to 24 is 6, right? Because rad 4 times rad 6 is rad 24, so that's what we want to break up the square root of 24 into. And now we simplify, right? The square root of 24, or sorry, square root of 4 simplifies to 2, and this rad 6 stays as a rad 6. All right, so my simplified answer for number 2 is 2 rad 6. All right, so today's lesson is really going to combine both of these skills here. All right, we're going to take solving equations with simplifying radicals, and we're going to just kind of combine those to solve quadratic equations using inverse operations. All right, and here are kind of the 3 kind of basic steps here for today's lesson on solving quadratic equations. All right, so first, we want to isolate the quadratic term, right? And the quadratic term is that x squared, right? The thing with a little exponent of 2 using inverse operations, all right? So kind of like in our warm-up or review problem number 1, right? We isolated the x by itself to solve, and now we're going to isolate the quadratic or the x squared term. All right, and then step 2 says, take the square root of both sides of the equation, but we must use a plus or minus sign in front of the radical expression. All right, and I'm going to talk about that more once we do some of these problems. All right, so this is the kind of the new piece of it, taking the square root of both sides. And when we do that, because it is a quadratic equation, right, meaning 2 x's, right, that's why we have 2 solutions here, and that's why we want to do a plus or minus sign. All right, and then the third step is going to simplify that radical expression using that largest perfect square factor, right? Just like what we did in the warm-up number 2 there. All right, so we're going to, like I said, we're going to combine both of those skills to do our solving of quadratic equations. All right, and again, here are these perfect square numbers, right, that we want to find, right? The square root of 4 is 2, right? The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5, and so on, right? So these numbers here in the squares, right, those are your perfect square factors that we need to find when we're simplifying radicals. All right, so the directions say to solve the following quadratic equations using inverse operations or square roots. All right, and we want exact answers only, which means no decimals. All right, so we're not just punching these numbers into our calculator and getting a decimal answer. I want exact answers using radicals. All right, so here we go. Number 3 is x squared is equal to 25. All right, so again, I need to isolate my quadratic term, right? In this case, it is isolated, right? There's nothing outside of my x squared. So now I'm ready to take the square root of both sides. All right, because I do the square root to both sides, because a square root undoes a square, just like how addition undoes subtraction, just like how multiplication undoes division, right? They're inverse operations. All right, so a square root is the inverse operation of a square. All right, and what you do to one side, you do to the other. All right, so now when I take the square root of my left side here, right, the square root of x squared is just x, all right, equals, all right, now because it is a quadratic, now I need this plus or minus sign. All right, anytime you solve a quadratic equation, we need to use a plus and minus sign because there are two solutions. And the square root of 25, in this case, 25 is a perfect square, right? The square root of 25 is just 5. So that means my final solution is x is equal to plus or minus 5. All right, so now let's try example 4 here. All right, example 4 says x squared is equal to 32. All right, so I should have said this earlier, but if you did not print this out, all right, make sure you write down these example problems down here, all right, and follow along like what I'm doing here in the video, all right? This is how you're gonna get your practice in for these solving these types of problems, all right? So if you weren't able to print this out, right, so write down on your sheet of paper, x squared is equal to 32, and follow these steps what I'm about to do to solve this problem. All right, so first things first is to isolate my quadratic term. Well, it is isolated, right? X squared is all by itself. So now I'm ready to take the square root of both sides. All right, and again, like I said earlier, if you take the square root of a square, it gets rid of it or it undoes it. All right, so on my left side, I'm left with x is equal to, all right, and because I'm taking the square root, and it's a quadratic equation, I have to put this plus or minus, all right? And now in this case, right, the square root of 32, I have to simplify that expression, all right, because 32 is not a perfect square. However, there is a perfect square that is a factor of 32. All right, so this is where I have to break down this square root of 32 into two numbers, all right, or two factors. All right, and I want to find the largest perfect square factor. So in this case, 16 is going to be my largest perfect square factor. All right, and if I needed to find that or check it out, right, this is where we're going to use this calculator here and just start dividing down the line, right? So we take that number 32 and I start dividing by one of these perfect square factors. Well, I know 25 is too big, so this one I would try 16. And this is why I get 16 and 2. All right, so this rad 32 is going to break down into rad 16 times rad 2. All right, and this rad 16 is my perfect square factor. So now I'm ready to finish simplifying or solving this problem. Right, so we get x is equal to plus or minus, right? This rad 16 is a 4, and this rad 2 stays as a rad 2. So my final solution is x is equal to plus or minus 4 rad 2. All right, let's do some more here. All right, and you should hopefully start making more sense by the time we finish this. All right, and if it's not, all right, again, please reach out to me so I can set up a time to review with you this week. All right, so number 5, all right, is x squared minus 18 is equal to 0, okay? So now in this case, right, my x squared term is not isolated yet because this minus 18 is here. So first thing I have to do is to isolate it using inverse operations, right? So that means I got to add this 18 over to the other side. So now we get x squared is equal to 18, right? Because 0 plus 18 is 18. All right, now my x squared term is isolated. So now I'm ready to take the square root of both sides. All right, if I square root an x squared, I just get x equals, and because I take the square root, it's always going to be a plus and minus. All right, and now my square root of 18, I need to break down, right? So I got to break down into two factors because 18 is not a perfect square, but there is a perfect square factor of 18, and that's going to be 9. All right, so the square root of 18, I'm going to break up into the square root of 9 times the square root of 2. All right, and now I'm ready to finish simplifying this radical expression here. All right, so I say x is equal to plus or minus 3 rad 2. All right, and number 6 here, all right, we have 2x squared is equal to 54. All right, so first thing I got to do is to isolate my quadratic term. All right, to isolate my x squared, I have to divide both sides by 2. So we get x squared is equal to 54 divided by 2 is 27. All right, now I'm ready to take the square root of both sides. So I take the square root of my left, and I take the square root of my right. All right, again, this square root gets rid of this square. So now I'm going to be left with x is equal to, and actually I'm going to try using my tools here, all right? So if you're doing the homework, maybe you should practice using some of these tools here with Cami, all right? If you don't have all these tools, all right, again, let me know and I can get you access to all these tools, all right? So I'm going to try this one using these tools here, all right? So we want to use this equation tool and here insert symbol, all right? And here we can change the font size, all right? And you see I've done this before because I have some of these recently used symbols up here, all right? So watch this. All right, I want to type in, I can start typing, right? X is equal to, right? So here's that plus or minus sign, plus or minus. Now my rad 27, I want to break up into a square root of 9. All right, and then for times, right, you can just use that x is fine, times the square root of 3. All right, and go ahead and hit enter, right? And here we go. All right, that would be my next line here. All right, so if you want to use this Cami feature to when you do the homework, all right, this is how you would do it. All right, and now I need my final solution here, right? So now again, equation. All right, and we can start typing here, right? X is equal to plus or minus. All right, and it kind of saves it up here that your kind of frequently used symbols will be saved up here in green. All right, and here are all the symbols they have access to. All right, so x is equal to plus or minus, well, the square root of 9 simplifies to 3, right? You can just type in 3 on your keyboard. And now you go rad 3. All right, again, if you just hover over it, if you want to move it or something, here's your final solution. All right, so I just want to show you a quick little way to do it for Cami. Yes, it takes a little bit longer, but that's one way you can use Cami here to help write out, right? If you don't have a stylus or it's hard for you to write with the mouse. All right, awesome. And again, I would just put in these like little square root symbols afterwards if you wanted to. But this is kind of the work that I'm looking for, right? I need to see that you break down the square root of 27 into the square root of 9 times square root of 3. And then I need to see that the square root of 9 simplifies to 3, and this rad 3 stays as a rad 3. All right, so let's try number 7. We have x squared plus 14 is equal to 23. All right, so again, my first things first is to isolate my variable, my quadratic term. So I'm going to subtract 14 to both sides. So now we get x squared is equal to 23 minus 14 is 9. All right, now that I isolated my quadratic term, now I'm ready to take the square root of both sides. All right, again, square root undoes my square, so my left side I'm left with x is equal to plus or minus. Now the square root of 9 is a perfect square, and that just simplifies to 3. And that is my final solution, right? X is equal to plus or minus 3. All right, to number 8. All right, now we have 2x squared minus 3 is equal to 13. All right, so now it's going to take 2 steps to isolate my quadratic term. All right, very much so like I did on number 1 of the example problem, right? The first thing we have to do here is to add 3 to both sides. So now we get 2x squared is equal to 13 plus 3 is 16. All right, now I still have to isolate it, right? Because this 2 is out in front of my quadratic, so I still have to isolate it, and I'm going to isolate it by dividing by 2, right? That's the inverse operation here. So now I get x squared is equal to 16 divided by 2 is 8. All right, and now I'm ready to take the square root of both sides. So I take the square root of my left side, and I take the square root of my right side. And now we get x is equal to plus or minus. All right, now my square root of 8, I have to break up into two radicals. And then the two radicals are going to break up 8 into are going to be 4 and 2, right? Because 4 times 2 is 8, and 4 is your perfect square factor. All right, so now I'm ready to finish this up by saying that x is equal to plus or minus 2 rad 2. Awesome. All right, we got two more to do here. All right, these last two are also going to be kind of two-step problems to isolate my quadratic term. All right, and then of course I got to finish simplifying the radical. All right, so first I have 4x squared plus 7 is equal to 103. All right, so my first step is going to be to subtract 7 to both sides. So then we get 4x squared is equal to 96. All right, now I'm ready to divide both sides by 4, because that is going to get me my quadratic term to become isolated. All right, so I'm going to take 96 and divide that by 4. All right, 96 divided by 4 gives me 24. All right, now that my quadratic term is isolated, now I'm ready to take the square root of both sides. All right, so I take the square root of my left side and I get x is equal to, all right, again, I have to remember to put a plus or minus symbol here. All right, now I'm going to break up this 24, right, into two factors. All right, so what are those two factors? What are those two numbers that I need to break up 24 into? Well, I got to find the largest perfect square that is a factor, and that's going to be the number 4. All right, and this other factor is going to be 6, right, because 4 times 6 is 24. So this rad 24, I break up into rad 4 times rad 6. And now I'm ready to finish solving this problem by simplifying this radical here. So we get x is equal to plus or minus 2 rad 6. Right, because the square root of 4 is 2, and this rad 6 stays as a rad 6. All right, how about you guys try this last one on your own here? Let's see you work through all the steps here, and let's see what you get for your final simplified solution here. All right, how did we do? All right, let's see. Did we add 10 first to both sides? We get 5x squared is equal to 200. All right, next we want to divide by 5. Right, and it's the inverse operation to isolate my quadratic term. All right, 200 divided by 5 is 40. All right, now that my quadratic term is isolated, now I'm ready to take the square root of both sides. All right, taking the square root of my left side of my x squared side, right, will give you just x, because that's what I want, to get x by itself. And now that I took the square root to both sides, all right, I have to remember this plus or minus sign. All right, and my square root of 40 is not a perfect square, so then that means we have to break up this 40 into two factors, all right? And one of these factors needs to be a perfect square. All right, so I'm going down the line here to find the largest perfect square that is a factor of 40, right? I just start dividing down the line here. Well, 36 is too big. I know 25 doesn't work, so let me try 16. All right, so 40 divided by 16. No, it's 2.5. That doesn't work. 40 divided by 9. Nope, that doesn't work. So let's see if 4 works. 40 divided by 4. Yep, it's 10. All right, so that means we're going to break up this rad 40 into rad 4 times rad 10. And now to finish this off, we're going to say that x is equal to plus or minus 2 rad 10. So if you got that, awesome, amazing, nice job. If you didn't, that's okay. All right, that's okay. We're going to keep working at this. This is not an easy skill to learn. All right, so now it's time to do a little practice. All right, so you have practice 8.5 to work on. All right, so you can either use Cami or print it out and take a picture and submit it to Schoology with a PDF, or just write it on a separate sheet of paper. Take a picture of it or scan it and send it to me. All right, awesome job. As always, email me if you have any questions, and we'll talk more on Thursday.